Welcome to the multivariable calculus section. In this section, we'll be discussing double integrals over rectangles. So, in single variable calculus, we had a graph on an xy coordinate plane, and we would make subintervals in order to derive the area under a general region or a curve. So, we would use rectangles, and we would say that the area under the curve is equal to the change in, or the sum of, all of the rectangles times the function, and that would give us the total area. However, in multivariable calculus, instead of finding the area under a curve, we are actually going to find the volume of an areaed object. So let's say we were given a rectangle. Well, if we took the double integral of this rectangle, we would actually find the volume of this rectangle that it occupies in three-dimensional space. So instead of solving for simply rectangles, two-dimensional flat rectangles with an x and a y component, in multivariable calculus, when we take the double integral, we're actually accounting for a miscellaneous z component, assuming that the density and the mass of this object will be proportionate throughout the entirety of the object. Whereas in triple integrals, this can be randomized. However, we don't want to get ahead of ourselves. So the volume in multivariable calculus is given by the following: the summation of ni equals 1 and the summation of m equals j equals 1 of our function f of x, y times the change in area. Or more simply noted, the double integral from a to b and from c to d of f of xy dx dy. Now this range, or this bound, is given by r equals ab cross cd. And essentially all this does is tell us where our boundaries are. So in the graph over here, we clearly represent, say we're given a rectangle with a two-dimensional region, and we wanted to find the volume, but we were only given the area, the two coordinates that it occupies. It occupies a AB and a CD. So essentially what's going on is this object here is a area, two-dimensional flat, and we're projecting a three-dimensional region. So I hope that helps a little bit for understanding the multivariable calculus. Thank you.